Kia ora everybody and welcome to the PLD for Dinosaur Loops. Bit of background about ByteEd. ByteEd are a digital technologies creation company who specialise in creating educational resources for all levels of schooling, particularly in AR, VR and programming. We work alongside digital experts who are our VR programmers and our 3D modelers, and alongside educationalists as well, who have got lots of experience in the classroom to help to design and create these resources that you're going to explore today. So today's tutorial, we're going to have a look at Dinosaur Loops, and we're going to explore what the kit is and how it works, how it introduces computational thinking, and then any extra resources that are available to you to use alongside the physical kits themselves. So just to recap from a previous video, we have got another one of these videos which focuses on Dinosaur Steps, the first kit in the Play Code Learn series. And in that video, there is an introduction to computational thinking and what is this. So if you haven't viewed that, or you want some more explanation on computational thinking and the concepts, I advise looking at that video first before this one. That video also goes on to exploring Dinosaur Steps, the first kit in the series, whereas today we are going to focus on Dinosaur Loops, the second kit in the Play Code Learn series. So what is computational thinking? Computational thinking is split into different concepts, the main concepts that you can see here. So we're going to be looking at algorithmic thinking, pattern recognition, logical thinking, decomposition, and abstraction today. The Dinosaur Loops kits, or in fact all the whole Play Code Learn kits, directly link to a wide range of curricula across the world. Obviously we're based in New Zealand, and so this is the current technology curriculum that we have, and you can see that as part of the technological areas in the technology curriculum, we have computational thinking for digital technologies and designing and developing digital outcomes. The Play Code Learn kits can help to support learning for both of these technological areas. It can also help to support other curriculum areas as well. So in particular, for example, this is from the New Zealand curriculum and Te Mātaiaho, and you can see that it's exploring links to literacy, communication, and numeracy. And we have tried to ensure that the Play Code Learn kits, not only do they help to support computer science and digital technologies in the classroom, but they can be used in an integrated way. So they can help and support a wide range of other curriculum subject areas, as you can see from this example here. So like we said, we have 3 kits in the series. Today we're going to be focusing on Dinosaur Loops. Each kit has sequential progressive learning as they work through the series. So in particular, you can see that we've identified the computational thinking and 3DO, designing and developing digital outcomes, progress outcomes from the curriculum here. And you can see that obviously we have that progressive learning content as the series progresses. The things that you can see in white there at the top of the Dinosaur Loops, so inputs, outputs, commands, iteration, efficiency, and pattern recognition, are going to be the main areas or concepts that we're going to explore today using the Dinosaur Loops kits. So what's the difference? Some of you may have used Dinosaur Steps. Well, Dinosaur Steps is an absolute beginner's introduction to coding and programming, essentially. Dinosaur Loops will take the information that they've learned in Dinosaur Steps and reinforce it and move them further on progressively as well. Don't worry if your students haven't used Dinosaur Steps. The way the content has been developed in the teaching resources means that you can actually start with Dinosaur Loops as well, because we reinforce all of the content from Dinosaur Steps previously. So let's explore Dinosaur Loops. So you will have a physical kit, and you can see that there are lots and lots of different components in the kit to help and support learning. We have what we call an unplugged to digital approach with the use of the Play Code Learn kits. So you can have a look at your kit. And so if you have a kit now, you can open up the kit and you can have a go at making a dinosaur land. Now, the dinosaur lands are created using these different tiles that you can see on the screen there. They are tessellating tiles and they enable creativity with the students because they can design and develop whatever shape land or put things together however they want to. So if you want to do background research into habitats and geological features, obviously you can do for them to help to develop the dinosaur land itself. Be aware that all the geological features on these different tiles here and the flora and fauna are all based on flora and fauna and features of the time period in which the dinosaurs lived. So we have tried to make it authentic learning for those students. And they can put this together however they wish to. So when you see this pause play icon, you can pause this video and you can have a go yourselves. So create the dinosaur land. So when you created your dinosaur land, what you've been doing is you've been using computational thinking, because when you observe students doing this, you will find that they will want to match things together. So for example, they will always try and match the blue in the river or the land or the sea together. And so what they're doing is they're using pattern recognition and color matching to be able to do that. They're also using algorithmic thinking because they think about a process and how to put these things together, and they test and trial things, and they'll rotate things, and they'll debug any problems that they can see. So you can see that they're actually starting to use computational thinking concepts when they're actually designing, creating their dinosaur land. They also can use decomposition because this is a physical representation of a decomposition task, because it's many, many small parts. And when you put it together, you make a whole. So it actually makes it easier to actually solve the problem. And it's also a simplified version of a physical version of abstraction, because the imagery on here is obviously much more simplified. It's made using simple geometric shapes in many of the cases on here. So they're actually taking away superfluous information and they're focusing on what's important. So yeah, so it's actually a great way to introduce using computational thinking concepts. So we'll focus on algorithmic thinking. So like we said before, dinosaur steps started off with things like sequential instructions, logical order, introduced algorithms, debugging and programming, and decomposition. Dinosaur Loops is now going to take that further, and we will have a quick look at some of those different concepts. So in algorithms, we have different kinds of inputs and outputs. Now, this directly links to technological systems. So if you look at the hardware, for example, have a think now about whether these are inputs or outputs. So hopefully you've managed to identify that we've got a range of inputs and outputs in a technological system. A mouse is an input, headphones is output, a monitor is an output, a keyboard is an input, and a tablet can be both, actually, can be inputs and outputs. So be aware that obviously you can have a range of different devices for inputs and outputs for actual digital hardware. You can also have inputs and outputs for computer programming and algorithms. And these are just some examples of types of algorithms. There are many different forms of algorithms out there, and you will introduce to those in the Dinosaur Steps PLD. But this is taking it a step further. So not only is it when you put the command cards as a series of instructions from the Dinosaur Loops kit, you can also have visual representations of algorithms. It doesn't just have to be a written list of code or instructions. So you can see here we're using a flowchart, and this is an example. And you can identify then the input and output. So what do you want to happen? And what do you want to trigger something to happen in a piece of software, for example? And you can see examples of inputs and outputs when the student's going to using the ByteEd app. The next thing to think about is instructions and logical sequential instructions. So here's a little activity you can do with your students. So imagine you're helping someone to park a car into a small space. What instructions would you need to give? And what would happen if your instructions are not clear? Okay, so I think you've probably had a bit of time to think about this. Obviously, you've probably identified if instructions aren't clear, there's probably going to be a car accident. So it's making sure that things are very clear, very specific, and are in a defined logical order or process that the students will go through. Okay, and then hopefully you'll be able to identify the input at the beginning and the output. The output would potentially be the car being parked in the correct spot. So how do we link this to the Dinosaur Loops kits? Well, what we can do is you can work through with this with me. So on your dinosaur land that you've created, you need to place a start and finish flags and potentially two of the dinosaurs that you've got in the kit. Can be anything and you can place them anywhere. Okay. So you can pause now and you can set up your dinosaur land. Doesn't have to be exactly like the example on the screen here. You can use your design and you can place them where you want to. The next step is to consider how you are going to complete the challenge. So the challenge is to get Explorer Ed. So you have Ed as a little stand-up card here, and you have to get Explorer Ed from the start to the finish. Now, what we do is with Dinosaur Loops, we introduce thinking and planning in between actually coding and programming the character to move around the board. So to be able to do this, what you need to do is you will need to start with one of these cards, which is the arrow card, which is a yellow arrow card with Explorer Ed on there. Yeah, as you can see on the screen as well. This is the direction card, and this enables you to decide which way Explorer Ed is going to face at the start of the board. So you would place Explorer Ed on the start command in whichever direction Ed is facing. Obviously, if you want to make it easy, you could face in the direction that you want him to go. If you want to make it more challenging for students, you could actually face it in the opposite direction, and they might have to start by actually putting commands in there to rotate Ed around so they can actually move in the correct direction. Then you plot the path using the footprint cards. So there's lots of little footprint cards in your kit. You can position them. And the idea is Ed, for this activity, is going to go and visit the dinosaurs. Now, in the kit as well, you will find there are eggs cards like this. You can use these because we have got challenges in the booklet too, where Ed is trying to save the dinosaur eggs from the erupting volcano. So there are challenge cards in the kit too that the students can work through, and that's the example that you'll see in the booklet, the handbook itself. But for this, what I want you to do is to plot a path using your footprints. Okay, so moving one square at a time to go and visit the two dinosaurs, and then obviously end up at the finish. So you can do that now. Once you have completed the planning of the path that Explorer Ed is going to follow, the next step is to write the algorithm. So this is where the different coloured arrow cards come in. Okay, so these are your commands. These are command cards, and these are the individual commands that Explorer Ed is going to follow. All right. So what this means is if it's a blue arrow, it's going to move forwards. Okay, so it's going to move forwards. Remember, it's based on the direction of the arrow card here. So here we're moving forwards. So if you could move upwards and here on this one. And if you look on the screen, the example there means we would move forwards or up, depending if you're based at the bottom of the map. Green arrows mean it's going to step backwards, because sometimes you may want to step backwards once you've visited something or pick something up potentially. And then we have now got, and this is what's different to the dinosaur steps kits, we've got right turns and left turns. Now what that means is Explorer Ed is going to stay still in one of the grid squares of the tiles and will rotate 90 degrees. Okay, so it works a little bit like your robots that you have in the classrooms too. So you will rotate within the square. He doesn't move forward, he doesn't move across the square. It means rotate in place. Yeah, so standing still, rotating 90 degrees. okay, each time. So what you're going to do is you're going to use the footprint path now to write your algorithm. And there's an example of writing the algorithm on the right-hand side there, so that you can see that we start at the top. So we've got some mini start and finish flags that you can use. If you notice the difference between them, yeah, so you've got ones that you place on the grid, and you've got ones that you can use for writing an algorithm. So you can place that at the start and the finish for the algorithm. And the algorithm can be written vertically, like I have got on the screen there, or it could be horizontally, or you may find that some students actually do it in the path, same shape as the footprint path. And you know what? It's fine as long as we know where to start and where to finish. I do encourage you to actually have it in either a horizontal line or a vertical line, because it will actually help you with the next steps. In fact, a vertical line is probably the best way to actually set this up for this activity. So your chance now is to use your footprints and to create an algorithm with sequential instructions. So the next thing you're going to do is, normally you get your students to work in groups for this, but you're going to actually test trial the algorithm. So one student would have Explorer Ed and place them on the start flag. That student would be responsible for moving Ed. You would have another student reading through the commands, enabling them to follow those commands. So you'd be going up, up, or forward, forward, turn right, and following along. So if they're successful, they will be able to follow the path that's created, and they'll be able to get to the finish successfully. They may find, though, that they have a problem. Okay, and this is where, as it says here, they need to debug. So they will find a bug in the commands and they will need to debug it. So how do we do that? Well, here is an example here. Okay, in this example, there is actually a bug in the code. So if you look at my example on the screen, look at the footprints and look at the algorithm and see if you can find the error, and then see if you can debug it. Okay, so have a look. So hopefully you managed to figure out that the bug or the error, was this particular command here. All right. And so then what you've got to do is you have to debug it, and then you have to solve the mistake or solve the error. All right. And this is where students can bring in prediction. They can try and figure out if things are going to work. And so they're trying to think forward as well when they're going into creating the algorithms. So the next step is actually to think about how we can take this algorithm, because actually that's a very, very long list of commands, and how we can make it so that the algorithm is more efficient. And the way we do that is by looking, first of all, for any repeats. So if you look at your algorithm, or you can look at my algorithm here that I have, can you see any single commands that are repeated? Okay, so have a look very carefully and spot the repeated commands. So hopefully you've noticed, first off, that we've got two up arrows or forward arrows that are repeated. There are two of them. Now, what we can do is we can try and shrink the code. And so what you can do is, instead of having two up arrows, side by side, we can now start to use these repeat cards, which are in the kit too. Okay, so what we would do is, as you can see the example there, instead of having two up arrows, we would have an up arrow and then times 2. Obviously, if there are 3 arrows, it would be times 3. And then what it does is it reduces it down to one single line of code, as opposed to having several lines of code. And what you're going to do is you're going to work through your algorithm and see if you can find any repeated commands, so individual commands. Okay. Once you've done that, it will look something like this. So you can see that my algorithm, my original algorithm, was quite long, going from right from the top to the bottom. But now, because of making it more efficient, we've spotted those repeated commands. And now I have repeats in there, which means we've actually shrunk down the algorithm. So you can now do this with your algorithm. The next step is to you carry on with iteration and start to use what we call loops, right, which is this green card here. So in this activity, what you do is you now look for repeated sections or series of commands. So as you can see at the top now, we have got was it up or forward times 2, turn right, up 4 times 2, turn right. So it's repeated twice. So instead of having 4 lines of commands, what we can actually have is 2 lines of commands, use a loop, and then repeat that twice. So you can see now we've actually shrunk it down as the example shows here. So this is just an alternative way to write the algorithm using iteration. And if we complete all of that, so that was just one example, if I combine and look at all the different sections, you can now see that that very, very long algorithm that we had can now be shrunk down into a much shorter code, essentially, or algorithm. And so now we have several repeats in there, we have several loops in there. And when you have a repeated section, it can be called a function, and a function can be saved and used later on in a computer program as well. So you can save things and use them later when you're actually going and converting to a digital format. So have a go yourselves. So the next step is looking at AR. So what is AR? AR is used, or augmented reality is used in a wide variety of different things nowadays. Okay, so we use them in education, you can see them in gaming, we can use them to help us to pick our furniture or our clothing, we can use them when we're visiting art galleries and museums. Yeah, AR is anywhere. And AR is the combination of digital and real life, yeah, when you're viewing something, as you can see from these examples here. AR is also a technological system. So it has an input, process, and output, like we were talking about before. So it uses a trigger image. Yeah. So in our things, we can use some of our our dinosaur cards. The app itself will convert that into a 3-dimensional model with animation and sound. So we can explore this. So you can go into your ByteEd app and you can pick on the Dinosaur Loops kit, and you'll see that there is a gallery button. So we're going to get you to explore it. So there's several things you can do in the gallery. One, you can interact with the different dinosaurs and you can learn about them. So those models you can tap, touch, they flap, they make noises, all those kinds of things, and you can explore all the dinosaurs in the kit. The other thing you can now do with this kit, which is a step up from Dinosaur Loops, is you can now scale up the dinosaurs, as you can see on the right-hand side there with the GIF. Yeah, so you can look in at scale and size and ratio if you want to. And then you can also get the students to take photographs. As you can see here, we've got students taking photographs of them holding the AR dinosaurs, which means you can set them challenges as well. And they could go outside, they could put the dinosaurs somewhere realistic in a realistic habitat if you wanted to. They could take a photograph, it saves to the gallery, and then they can download those photographs and use them for other purposes. So linking to science, linking to writing, it's entirely up to you what you want to do with those imagery. So to log in to the app itself, yeah, you will get this login system, as you can see here. Then you can select Dinosaur Loops, and then you can hop into the gallery as it's showing you on here. If you do not have a login or you've forgotten your login, you can go in through as user's guest. It just will not save any of your work. So go and explore the app. The second part, which makes our Dinosaur Loops different to Dinosaur Steps, is now you can also create your AR land or dinosaur land in an AR way, so digitally. So not only can you create it physically using the unplugged kits, you can also go into explore mode, and you can see that you can click and drag the tiles, and you can position them in different places, you can rotate them, you can change the design, you can have randomized tiles popped in there. So there were 2 yellow scroll slides that you can see at the bottom there with the little dice next to them. That means they're randomized. But you can also tap on individual ones and change them, as you can see there in the little video playing. Once you've created your dinosaur land, it can match whatever you've created physically if you want to, or it can be something that is totally brand new. You can save your land, so you can save or you can load pre-existing lands. Then what you do is you press AR and scan one of the tiles, okay, that's usually in the kit, using a space. It doesn't have to be a whole series of tiles, just one or two of them will do. And then the dinosaur land that you have created will pop up three-dimensionally. So they're exploring creation with AR using their own designs and their own creativity. So have a go exploring creating an AR land. The last step to do with the dinosaur loops is obviously taking algorithms and put them into programming. So what we can do is we use the app again. You can go into the challenge section for this particular part, and there are 60 pre-made challenges in there to help you. If you want to do a challenge, you can have it so it matches the actual dinosaur land itself, the physical kit. So it would be advisable when students are first starting out to create the dinosaur land physically that matches the booklet on page 12. Okay, and then the AR, when it pops up, will match the actual physical land that they're working on. So it just makes it easy for the students to match what's going on. Once they've done that, you can select your challenge, and the challenges unlock as you work through them and you're successful. And essentially what you do is you scan the land and then you program. So there were pre-made challenges that pop up. There'll be a start and a finish, and you've got to get ByteEd obviously from the start to the finish. And it shows you very clearly in the app how to do that. And then you use the command arrows and you can click and drag them to the side. If you position 2 forward arrows together, so one on top of one another, it actually creates a repeat. And then you can also add loops into the programming too. So, and when you're happy, so you can see some examples on here of the clicking and dragging of the command blocks. You can see you can put them on top of one another, so it turns into a repeat. And then when you're ready, you can press the play icon that's on there, and you are ready to test, and it will run. So ByteEd will travel, as you can see here. As the algorithm or the program is running, the arrow will move down just to show students where they're up to, and then they can check and see when they're successful. Okay. Many of the activities in here, the students have to go and visit different dinosaurs. Okay. And then you can practice writing programs. So when you're successful, a congratulations pop-up will pop up on there, and the numbers in the challenges will turn into little mini badges for the students so they know where they've got to. So you can practice writing challenges. The other aspects that we do have with the dinosaur kits as well is we have a whole heap of teaching resources that are online on the portal to help and support you. Please go into the website and check these out. There are all the teaching modules on there. There's assessment things on there. There's how to unplugged activities. There's extension challenge cards, as you can see in here. There's information booklets. There's dino facts. There's ebooks. There's even 3D printing if you want to go into that thing. As teachers in the app, you can also check the progress of your students by going into the classroom profiles, and you can actually add your students in so you can check their progress, how far they've got and what they're up to too. And be aware that you've got the new dinosaur kits. So on the back of the tiles and on the back of the dinosaurs, there are these black and white imagery. Now, what's happening is in the very short while, we will be releasing themes. So the first theme we're going to release is the farm theme, and then we have a space theme, as you can see here. Once they are released, it means that students will be able to do algorithmic thinking and programming using a wider variety of themes, so not just the dinosaurs. If you are interested, and because you go through PLD, we can help to support you with endorsements through ByteEd. Please feel free to have a look at becoming a teacher ambassador for us, just to showcase who we are and take things on a little bit deeper and further. And we also have ByteEd certified schools too. So to access the website, you will find that you will have got a welcome email with the codes and the login details. You go to the login information, as you can see here on the byteed.com website. When you head into there, you can sign in and you go into the Dinosaur Loops course. And you can see that there's lots and lots of resources there for you that you can just click, drag and use to your heart's content. If you want to keep in contact in the future or find out more things, then please head to our social media channels and our website. Ka kite.